My name is Jeremy Cowles. I'm the Tiltbrush technical lead, and this is a re-recording of my part of the SIGGRAPH 2018 Birds of a Feather for Pixar's USD. So I'm going to talk about Tiltbrush integration with Universal Scene Description as well as the USD Unity SDK. So for those of you who don't know, Tiltbrush is a VR painting application. You put on the headset, and then you're able to paint in 3D space. Once you create a painting, you can then reload it, play it back. It plays back sketch by sketch in the exact order that the artist painted it. We also support exporting the sketch to traditional 3D formats like FBX and now USD. And people use this data to then create something completely new. So for instance, this is a Nissan commercial that was created with Tiltbrush. There have also been games and short films and music videos, stuff like that. Previously, we only supported FBX, which has been kind of a pain because there are several limitations on the way the data is stored and storing things like custom data or which would be stuff for us like stroke timings and things like that, was cumbersome because it wasn't directly supported by FBX and was also often lossy in the transport. And so we ended up storing data in JSON and FBX. And now with the USD integration, we can store everything in USD. So the way this works is there's a USD Unity SDK, which was open sourced earlier this year. And so Tiltbrush uses this SDK to export its data to USD, and then that data can be re-imported back into Unity or anything that supports USD import. This SDK is available on GitHub. This is what the GitHub page looks like. And there are 3 basic components to it. So the PXR namespace is a faithful translation of the C++ USD API. So if you're familiar with the C++ API, the PXR namespace within this library will be very familiar. USD.NET namespace provides C# serialization semantics. So create a C# class and be able to serialize that directly to USD without calling the USD API. So this is more intended for C# developers. And then the USD.NET.Unity namespace provides USD engine integration, so support for native Unity types like vector3 or bounds or other things like this. So here's an example of using the USD.NET, the high-level API. In 4 lines of code, you can create a USD file. And if you've used the USD API, you should know that this is actually pretty efficient in terms of how much code you have to write. Here's an example of a class that we actually use in Tiltbrush called brush sample. So sample in the sense of like signal processing sample, like it's a sample over time that can be time sampled out to USD. And here we're using, it's inheriting from mesh sample, so it is mesh data, and we're adding on top of that some Tiltbrush specific data. So the brush GUID, as well as some stroke info. And notice that the brush GUID is tagged as custom data. That means that when it's serialized to USD, it'll be in the custom data section for the prim. And notice also that this stroke data is a nested class. So stroke batch info is a separate class. The serializer will kind of just recurse into this and write that out to USD. And so this is what it looks like in USD view and export from Tiltbrush. And here you notice the stroke data has been kind of nested within this namespace stroke, exactly as it was declared. And all the geometry and curve data comes with it. So the blue lines here are the actual strokes that were painted by the artist, and the shaded geometry is the geometry that we generated in Tiltbrush that's been baked out to USD. Here's a visualization of the geometry hidden so that you can see just the strokes. They also have shaders bound. And so this is what the artist actually painted. So we use this heavily on our VR experience that's in the immersive pavilion called A Show of Kindness. This was a small production by artist Peter Chan and myself. I did the engineering part and he was the artist on the project. And so we had this idea for a sketch that was much bigger than we could store in Tiltbrush or build in Tiltbrush kind of natively. And so we broke the scene down into several components, and then we also reanimated them using the exported stroke timings. So here you can see an example where the stroke timings have been kind of resequenced. Normally in Tilt Brush, one stroke draws in at a time, kind of one after another. And in this case, we're using a sphere to draw all the strokes that are within some certain radius, as well as apply the original ordering. So it's kind of like, if the stroke is within the sphere, choose the sphere that was most recently drawn in the original stroke ordering. We also made a teaser for the video, and in Tilt Brush there is a VR kind of virtual camera, which you can see I'm holding above my head here. And so we recorded the video in Tilt Brush with some smoothing on the controller, and this real-time encodes a video and outputs an MP4 file. It also lets you re-render the video, so you can get rid of any kind of hitches or glitches that were in the video due to VR tracking. It also lets you re-render in 360 stereo and high resolution. It also outputs a USD file with the camera path. So here I exported the geometry and then re-exported the camera path. And if you're kind of a hardcore VFX person, from here you can go crazy. You can bring this into Maya or whatever you want, kind of re-render it and do new interesting things with it. It's shown here in USD view. And also, to put the camera path and the geometry back together, I used the sublayer feature of USD. And so here you can see I used the USD Unity SDK to re-import this back into Unity, and you can see on the right it has the stroke timings and offsets that were originally authored in Tilt Brush. So that's it. You can check out the USD Unity SDK on GitHub and contact tiltbrush@google.com if you have any questions about using Tilt Brush for production. Thanks.